Morning, guys. We're going to talk about graphs of sine and cosine today. All right, so let's look at a sine function. Here's a sine function, which we'll go ahead and highlight a little bit. Love the sine function. It's such a pretty function. It's nice and symmetric and continuous and all that good stuff. So, whoa, that's a horrible color. That's not bad. All right, so sine function. Let's look at properties of it. So, first property is the domain's all real numbers. Okay? So I can put in any number along the x-axis I want. I'm going to get an answer. The range is all the real numbers from -1 to 1 inclusive, which means inclusive means yes, -1 and 1 are also answers. So this just goes anything in between 1 and -1, there's going to be an answer. Nothing outside of that. The sine function is odd. So if I took this thing and I rotated it 180 degrees around the origin, I'd get the exact same function. You'd never even know that I did anything to it. It's periodic with a period of 2 pi, which, you know, we can see there's a distance of 2 pi, and I get all those answers. There's this another distance of 2 pi, I get the same exact answers. The x-intercepts are -2 pi, -pi, 0 pi, 2 pi. So it just, every pi I'm going to have a 0. The maximum values are 1, which occur at -3 pi over 2, pi over 2, 5 pi over 2, 9 pi over 2. And it has minimum values of -1 at -pi over 2, 3 pi over 2, 7 pi over 2, and 11 pi over 2. Okay. And so on. So there's your properties of sine functions. Let's see here. That's all we got on that page. So graphing transformations of sine function. So this goes back to last semester, graphing variation. So if I take a function and I add or subtract a number outside the function, that just moves the function up or down. If I add, it moves it up. And if I subtract, it moves the function down. Okay, so for example, this might not show on the video, so we'll go ahead and brighten it up here a little bit. So here's my sine function. Whoops, that's awful. There's my sine function. Now, if I want the sine of x plus 3, I just move the key points up 3. So the key points would be the zeros, the maximums, and the minimums, right? So the minimum is -1, well, here the minimum is 2. The maximum was 1, so here it's 4. The zeros were at 0, obviously, and here they're 3. Okay? So it just took this function and moved it up 3. That was it. Done. Okay, now down here, I have my sine function, my original sine function, again, is going to be the green one here. And then if I want to graph sine of x minus 2, that's just going to take this graph and move it down 2. Okay, so the 1s are now at -1, the -1s are now at -3, and the zeros are now at -2. So I get this curve right here. So adding or subtracting a number to the end of a function, or the beginning, is pretty easy to graph using transformations. Just got to be able to graph the original one and then you just move it up or down, whatever that number is. Okay, now this is a little different because now I added or subtracted a number inside the function. That does not move it up or down. That moves it to the left or the right. Okay, now it's a little it's a little backwards thinking for a lot of people because you think, oh, negative, I'm going to move it to the left, but that's not the case. Negative, you're going to move it to the right. Positive, you're going to move it to the left. Okay? So, yeah, so subtracting a number moves the function to the right, adding a number moves the function to the left. So if I have sine x plus pi over 4, okay, that's going to take my sine function, which is the green one right here, and I always like to graph from negative 2 pi to 2 pi. And it's going to move all the key points pi over 4 to the left. So this the maximum here is at pi over 2. This is going to be at pi over 4. The 0 is at pi, so it's going to be at 3 pi over 4. I would graph some of these key points just to make it easy to graph this thing, and then go through and fill in the gaps. So it just moved it slightly to the left. Now we moved to the left, obviously we need to move something to the right, right? So here, I have my original sine function is, again, the green one. So there's my sine. Now, if I move it 3 pi over 4 to the right, okay, remember this space is a half a pi right here, so it's going to be one of those and a half. So my key point here got moved over to here. Okay, I just move those key points again, and I get this nice, can't seem to trace well today, but there's sine minus 3 pi over 4. It's just shifted, you know, this point was here, so it gets shifted this way, 3 pi over 4. Okay, adding a negative to the front of a function just flips that function upside down. So if I want to graph y equals negative sine, well, that's going to take my sine function, which is this green one, now the nice thing about this is all the zeros stay 0. All the negatives become positive, and all the positives become negative, so it just flips this thing upside down. Then I get this cool kind of double helix DNA looking thing right here. So that's kind of cool. All right. All right, stretching a function vertically. So if I take a number bigger than 1 and I slap it on the front of this thing, so instead of graphing sine x, I'm graphing 2 sine x, that's just going to double this thing. It's going to stretch it vertically. So all the 1s become 2s, all the 0s still stay 0, and all the negative 1s become negative 2s. So again, here's my original sine. I want to make sure you can see it on the video, so that's why I'm taking the time to highlight this. So there's my sine x, or sine theta. Now 2 sine x. So the 1 becomes 2. The zeros all stay the same. The negative 1 becomes negative 2. Like I said, when I do this, I generally graph the key points like that, and then I just go back and kind of trace in the gaps as best I can. Sometimes that's really easy to do, like in this case, and sometimes it's not so easy to do. Now, if this number was less than 1, okay, like 1/2, that would shrink this thing. It would compress it down because all the answers would be half of what they were before. Now, in this case, the number 2 is called the amplitude. right, so if you see a number out here, this is called the amplitude. All right? And if it's negative, you use the absolute value. So if I had -2 out there, the only difference would be it would flip this red one upside down, okay? But the amplitude is still 2. It's not going to be -2, it's 2. Make sure you get that right, okay? Answering an amplitude question is the easiest question in the world. However, you need to get it exactly right, or it's going to be wrong, okay? So when y equals a times sine x, or cosine x, or tangent x, the amplitude is going to be the a, the absolute value of the a. Okay, changing the period. Graphing a function of the form y equals sine wx will alter the period of the function. Okay, so as you know, both sine and cosine have a period of 2 pi. All right, so here's a theorem that you want to know. If w is greater than 0, the amplitude and period of y equals a sine wx or y equals a cosine wx are defined as follows. The amplitude is the absolute value of a. You should never miss that question. And the period, which for some reason is called t, I'm not sure why, is 2 pi divided by w. Now there's a couple of ways to graph that, and I'm going to show you a trick for making it an easy way to graph it. Because sometimes when you change the period, depending on what the period is, it might not be very easy to graph on the graph. And I always require you to show your transformations. Okay, so you would always start, like if you were going to graph y equals, I don't know, 1/2 sine 2x minus 3 plus 4. There would be a lot of transformations in there. Okay, so this is going to be, you're going to start with the sine, you're going to graph the sine, then you're going to move it up 4, then you're going to move it to the left or the right 3, and then you're going to change the, then you're going to, I would probably do this right away too, is change the amplitude to half of what it was, and then change the period, okay? And I'll show you how to do that in an easy way. So you're going to want some colored pencils maybe when you do this. Now, if you're using a graphing utility, it's not too bad. Okay, so graphing y equals cosine of 3x. Okay, so my original cosine function is this function right here. There's your cosine x. Now 3 cosine x changes the period. So what's the new period? The period is going to be, and I just call it p for period, the period is going to be 2 pi divided by, in this case, 3. So the period is now 2/3 pi, okay? Which basically means, you know, here's my original period. I got to get all that in 2/3 of a pi. So here's a pi, there's 2/3 of a pi. I get a full from 1 down to -1 back to 1. So 1 down to -1 back to 1 in 2/3 of a pi. Now this is actually kind of a tough one to graph. Let's redraw it so that you can make sure you see it well. Okay, so there's your graph. Now some of them are easier than this. Some of them can be even way harder than that to graph. Okay, so I'll show you a way that you can graph the new period very simply. Okay, so determine the amplitude and period of y equals 3 cosine 4x. Okay, so this is an easy problem. The period is just going to be 3. Okay, it's right there. I'm sorry, the amplitude. What am I talking about? All right, the period, since its cosine has a period of 2 pi, I'm going to divide by whatever number's in here multiplied by x, so that's going to be 4. So the period is going to be, that'll cancel with that and leave you with pi over 2. Period's pi over 2. Okay, so if I was going to graph this thing, instead of going from 1 to -1, I'm going to go from 3 to -3. Okay, and I always like the numbers pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so if I take my cosine, this cosine. So if I take my original one, my original cosine is going to look like this. Okay, there's my cosine. Now, 3 cosine, I'm going to do that next. 3 cosine is just going to go here, here. This is going to go to -3, 0, +3, 0, -3, 0, +3. So this thing's going to go like this. So that's 3 cosine theta. Okay, now remember that this was pi over 2, this was pi, this was 3 pi over 2, and this is 2 pi. Okay, negative pi over 2 here, negative pi, negative 3 pi over 2, and negative 2 pi. All right, if I want to change the graph for the period, I don't want to redraw this graph. Even though if the period's pi over 2, it's really not that difficult. But there's an easier way to do this. And here's what you do. Remember, the period on this is 0 to 2 pi, right? So what I can do, if the period is supposed to be pi over 2 now, I go and I change 2 pi to pi over 2. Now, on my graph, I change the scale is what I do, right? Now, this is half of that, so this is now pi over 4. This is half of this one, so this is now pi over 8. So this one is always that one plus that one, so this would be 3 pi over 8. And now these are just negatives, so this is negative pi over 2, negative 3 pi over 8, negative pi over 4, and negative pi over 8. Okay, so, oh, you know what? The blue one is now the answer. The blue one is now 3 cosine, what was it? 4x. Ah. Okay, when I changed the scale, it changed the blue one to the final answer. Okay, and so that makes it a lot easier. I don't have to get all these tiny little up and down things into my graph. I just change the scale. So you can, it's basically cheating, but it's legal cheating. Okay, and it's no more difficult to do for, I mean, this one was not a hard one. I could have graphed this without changing the scale, but if I had had a really, really difficult one, it's really no more difficult to change the scale on any one than it would be to change it on this one. Okay, so write an equation for a sine function with an amplitude of 2 and a period of 4 pi. Okay, so we're going to write y equals a sine wx. Okay, well, the amplitude's easy. That's just going to go right there. Okay, so y is going to be 2 times sine of something times x. Okay, So then remember that the period is 2 pi divided by w, right? So I need the period to be 4 pi. So that's going to be 2 pi divided by w. So I need to solve for w. So I'm going to multiply both sides by w. And then I'm going to divide by 4 pi. And that's going to reduce because the pi's are going to cancel out, and the 2 and the 4 are going to cancel and be 1/2. So my w is just going to be 1/2. And there's my equation. Ta-da, y equals 2 sine 1/2 x. Okay. Write an equation for a cosine function with an amplitude of 4 and a period of 1. Okay, so let's start with our original equation. Y is going to be a cosine wx. All right, so again, my amplitude is right there. That's going to be 4. So this is going to be y equals 4 times cosine of wx. Okay, so then I got to figure out what w is. So w is going to come from this. My period is going to equal 2 pi divided by w, right? So again, my period has to be 1. And you can probably do this in your head. What's going to take 2 pi and divide it by w and get 1? Well, w is going to be 2 pi. So my w is going to go right there, 2 pi. And there's my new equation. Let's do this in something fancy, because this is kind of cool. There you go. 4 cosine 2 pi x. How exciting that is. Okay. Moving on. Write an equation for the graph. So now they give you the graph and you got to write the equation. Okay? So let's go ahead and write down our general formula. Y equals A. Now I got to determine, is this a sine or a cosine? Well, it could be either one, really. But we're going to go with the simplest one. Since it goes through the origin and it's got like a sine or cosine curve, we're going to go with this is going to be a sine. If it went through 4 here, we would use a cosine. Okay, so now we got to figure out what is the amplitude and what is W. Okay, so the amplitude is easy. This thing is centered on 0, and it goes to 4 and negative 4. And so that's going to be 4. So y is going to be 4 sine something x. So we got to figure out what the something is. Okay. Now here's what's the period. So we're going to look here at the period. The period goes from here to here. That's 8 pi on this graph. So the period, remember, is 2 pi divided by w, and we said that the period was 8 pi. So we just got to figure out what w is. So we're going to multiply both sides by w, and then we're going to divide by 8 pi. And then the pi's are going to cancel, and 2 divided by 8 is 1/4, so this is going to be 1/4. There we go. The equation of that is going to be 4 sine 1/4 x. Or you can put a theta there instead of an x. And we're done. Okay, what's behind this? Oh, okay. So we got an assignment. We're done with this. Now, generally I'm doing this on President's Day. So we're a little late this year because of the COVID thing. But there you go. Here's your assignment. And yes, this problem is missing problem number 22 because Mr. Lippy can't count. So go ahead and don't freak out about that. There is no problem 22 on this assignment. So good luck with that. Give it a try, and I will see you next time.